So we're going to continue in our Chapter 4 review. We have problem 10, and so we're given a graph. We're going to look at the zeros, so the x-intercepts, and if it crosses, that's an odd multiplicity. If it touches and turns around, that's an even multiplicity. You should have as many of those as your degree. And so this one tells us it's the graph of a fourth degree polynomial. So we should have 4 zeros. And they would like us to complete the table. So they have shown us the root that is -5, which is here. So if we count and make sure we have them all, this would be 1, 2, and this one can be even, so 3, 4. That would take care of our zeros. And it actually tells us one of them is 2. So this will be 5, would be this spot. All right, so the root with -5, the multiplicity is 1. Sorry, I just hit the key there. It crosses. And they did add up to 4. That's important. All right. Our next one, which has multiplicity 2, is going to be this one that touches and turns around. It would not be this one because this is going to be odd. So 5 would be the root of multiplicity 2. And this is touches and turns around. And so that just leaves one more 0, which is -1. So it's a root or a 0, same thing. And it will be multiplicity 1, which is odd, crosses, so it's matching the behavior, and these multiplicities all add up to the degree. So 1, 2, 3, 4. So we're good. Next, we'll look at question 11. We have the function -13x cubed times parentheses x minus 14 to the 6th, x plus 9, parentheses to the 2nd. So it says determine the zeros of h and the multiplicity of each 0. Also describe the behavior of the graph at each spot. So your exponent is going to tell you about your multiplicity, and this is already in factored form. So for this piece, you're not worried about the -13, but you're going to set each one equal to 0 and solve. So x to the 3rd equal to 0, x has to be 0, but has a multiplicity of 3. And we'll write that here, multiplicity 3, which is odd, so it's going to cross. That's your behavior at 0. Okay. Next, if we set this one equal to 0 to solve, it will be x equals 14. This one has an even multiplicity, multiplicity 6, which is even, and so it will touch and turn around. And our last one, x plus 9, set it equal to 0, and it has multiplicity 2. We'll solve it first. X equals -9. Multiplicity 2. That's also even. It will touch and turn around. So let's look at these questions. The multiplicity of the least root, right? So our least root is -9. Its multiplicity is 2. the multiplicity of the greatest root, our greatest root is going to be 14, and it has multiplicity 6, and the other root will be 0, and it has multiplicity 3. So we can just double check here. Negative 9 is 2, 14 is 6, and 0 is 3. So we're good there. Then it asks about the behavior. At the least root, which is x equals negative 9, it has an even multiplicity, so it's going to touch. And it lets us choose, touches the x-axis and turns around. Right. At the greatest root, which will be 14, it has even, it's also going to touch and turn around. And at the other root, x equals 0, this one has odd, so it's going to cross. The x-axis. Let's look at question 12. It also asks us about the zeros and the multiplicity. This problem is not in factored form for us, so we are going to have to factor, set it equal to 0, and solve. So we'll have to work harder to find the zeros. So let's go ahead and set it equal to 0. And on this one, it's 4 terms. We can try to factor by grouping. That's a standard thing to try with 4 terms. In the first group, we can take out an x squared, and that leaves x plus 8. In the second group, it starts with negative, so choose a negative. So we can take a negative 9, and that will leave x. Be careful here, you took the negative to the outside, so it comes out of this one. And we're pulling out 9, it will leave an 8. Just divide if you get stuck. And now what we hoped for was a common binomial. We did get that. So we have x plus 8. And then we have x squared minus 9, picking up the other pieces. X squared minus 9 will continue to factor to x plus 3, x minus 3. So these are our factors. All of our zeros are going to be multiplicity 1 because none of these factors occurs more than once. So we'll solve each one setting equal to 0. So this will be x equals negative 8, x equals negative 3, x equals positive 3. And let's just double check the degree. The degree of the function is 3. So 3 zeros, we're good there. They all have multiplicity 1, and they're all going to cross. So we'll just double check over here. The multiplicity of the least root. So the least root will be our negative 8. Multiplicity is 1. The multiplicity of the greatest root would be 3. Its multiplicity would also be 1. And the other root will be negative 3. And its multiplicity is also 1. At the least root of x equals negative 8, the graph will cross. At the greatest root, which is x equals 3, the graph will cross. And at the other root of x equals negative 3, the graph will also cross. Look at problem 15. This one is kind of a backwards thought process. You're looking for the equation or the function. So they have given us some conditions. It is a polynomial of degree 6. It has a leading coefficient of 1. And these are the zeros with their multiplicity. So first of all, to have a 0 at x equals negative 6, that comes from a factor of x plus 6. She would set it equal to 0 and solve, gives you negative 6. It has a multiplicity of 2, so our exponent there will be 2. Next, we have a 0 at x equals negative 3. So this would be x plus 3. And it has a multiplicity of 1, so we don't have to write that exponent. And last, we have a 0 at x equals 5. So this comes from x equals minus 5, because when you set it equal to 0 and solve, you add the 5. This one has multiplicity of 3. That gives all of our zeros, because we were degree 6, so 2 plus 1 is 3, and 3 is 6. And the leading coefficient is 1. Since it's 1, I don't know that you really have to write it. So this is P of x equals this. We didn't have any other point to give us a condition to make a different number here, and they told us the leading coefficient was 1. So let's look. They did write the 1. I don't know that you have to put it. I did not put this 1 on this one, which is fine. It's the same thing. Next, we have problem 16, and they've given us a graph. They're telling us it is complete, so it displays all the roots and the end behaviors, and the y-intercept of the graph. Use the graph to answer the following questions, and it tells us, note that the x and y intercepts are integer values. That's good. So we don't have any fractions going on here. It says list all the roots with even multiplicity. All right, so looks to me like we have 2 roots, and both are going to have multiplicity because it touches and turns around. It does not cross through the x-axis. So 1 and 3 are going to be our zeros. They're using the term root this time. So these are our roots, and they're going to have even multiplicity. I have to look at the rest of the questions. So list all our roots with even multiplicity. So this is just going to be 1 and 3. So we're good there. List all the roots with odd multiplicity. There are none. There is not a place where it crosses the x-axis. So we would have to choose this one. And they ask us for the y-intercept, which we're just supposed to take from the graph. So it's the point where the graph crosses the y-axis, which is going to be 3. And remember, on a y-intercept, the x-coordinate is 0. And they ask us for ordered pair form. And then they ask us to determine the factored form of the polynomial. And here they give us a hint that the degree is 4. So these are going to be factors of multiplicity 2 each. So our factors, so we're going to have f of x equals, now they did not tell us the leading coefficient on this one, so it's going to be a. To get this root, it's going to come from x minus 1, and it will be squared. The other one, 3 will come from x minus 3, and it will be squared. We have to figure out the a. So we are going to, when you find the y-intercept, you plug 0 into x. So we're going to plug 0 through. F of x is y, so it will equal 3, but we're plugging in 0 for x. So 0 for x gives us 3 for y. So we have to plug the 0 into each one. So we get numbers here. So we get -1, and we're going to square it. Gives us 1. We get -3. We're going to square it. Gives us 9. And so we have 1 times 9 is 9. So we have 9a equals 3. Divide by 9. And we can reduce. So our a equals 1/3. And now we can put our function together. So our f of x is going to be 1/3 times x minus 1 squared times x minus 3 squared. You don't have to multiply it out. They should accept this answer. 1/3. They just switch the order, which is fine because it's all multiplication. Next, we'll have a couple of problems from section 4.3. They're in our review. And these are using synthetic division. So problem 18, we're going to set this up with synthetic division. Remember, you need to go to descending order. And if you have any missing terms, you're going to put 0. So we'll start with our grid. And I'm just going to be careful. I'm not going to rewrite it. All right, so x cubed is the highest exponent, so it should go first. Its coefficient is a -1. Right, then we go to x squared. Coefficient is 5. X to the first, coefficient is -11. And constant is -17. You skip a row. The piece you divide by is always the opposite sign of this because your form is x minus c. So opposite sign here would be a2. You bring your first one down below the line, and with all of these, you're going to multiply and combine. So we're going to multiply. 1 times -2. I'm sorry, -1 times 2 gives us -2. Goes in the next column. Combine. This gives us 3. Then you start over. 3 times 2 is 6. Goes in the next column. Combine. This will give us -5. Multiply again. Gives us -10. And this will give us a -27 for a remainder. To put it back together, you're going to drop 1 degree lower than where you started. We started with the highest exponent, x to the third. So this is going to go back as x squared. So -1x squared plus 3x minus 5. And the form they ask for is here. This will be our first polynomial. They want the remainder as a fraction. It is -27. So plus a -27 over your complete divisor, x minus 2. So let's see if we have that right. -x squared plus 3x minus 5 plus and -27 over x minus 2. We'll look at one more problem. Problem 19. So we're going to do a synthetic division to evaluate it. And then we have a different form they want the answer. So we'll go first with synthetic division. So we'll make our grid. Opposite sign here, so it will be a +5. We are in descending order this time, so pick off your coefficients. So 1 for x cubed minus 18 for x squared, 107 for x, and minus 210. So it was not missing any terms. Bring your first one down below the line. So we're going to multiply. 1 times 5 is 5, goes into the next column. Combine. So you would want your calculator probably with this one. Negative 13. Negative 13 times 5 gives a negative 65. Combine gives 42. Multiply again. 42 times 5 gives us 210. And these combine to give us 0. That's important when we get a 0. It means there's no remainder, which also means 5 is a root. So let's put it back to get the answer form they want. We drop 1 degree lower, which will be x squared minus 13x plus 42. So that's our polynomial coming out of it, right? And they want 2 pieces multiplied. So the other thing that is your divisor. And they actually want the divisor first. Our divisor is x minus 5. So the way they want this answer is divisor x minus 5 times quotient x squared minus 13x plus 42. And then they would want us to put a remainder. Well, our remainder is 0. So let's double check our answers. So this is the divisor, which they have listed first. Our quotient, x squared minus 13x plus 42. And 0 for a remainder. So we're good there. They have one more question. Use the above result to determine if x minus 5 is a factor of this polynomial. Because the remainder is 0, x minus 5 is a factor. So yes, x minus 5 is a factor. I'm going to abbreviate here because remainder equals 0. So this one should be a yes.